Welcome back to another episode of my derivatives examples series, or part of my derivatives examples series, where I basically write 3 examples, go through them, show you how to do them. This is the 11th episode. From the first one, they were easy. As they kept going, they got progressively harder, and they will continue to get progressively harder. Unless this one down here, it might seem simple, but unless you've actually done one like this, you may want to stick around because it's a little bit different to how most people would think this is done. But anyway, or skip to this, doesn't bother. But if you haven't done this, physically done this before, or seen someone do something like this, where you have a function to the power of a function, it's probably a good idea to watch it. But anyway, I'll go on with example 1. Example 1, we have y equals log to the base 10, 1 plus cos x. The derivative is very simple. I'm going to use the log law, just the actual log law. I'm not going to convert it to natural logs. I'm just going to use the actual log law, which will mean 1 over 1 plus cos x ln 10, which means I basically have 1 over this multiplied by the natural log of the base, multiplied by the derivative of the inside, which is negative sine x. Because 1 goes to nothing and cos goes to negative sine. Should really put a dash there. So that'll equal negative sine x over 1 plus cos x ln 10. And that's it. That's the derivative of this. Now I'm basically on the next one going to convert it all to natural logs. Show you different ways of solving things. That's not it. It's log to the base of 2 x multiplied by log to the base of 5 x. Okay, so I haven't done any derivatives yet. What I'm going to do is just convert it all to logs. So the outside, what we're going to do is you have natural log, change of base rule. So we'll have the same base. In this case, it's log to the base of e, which is the natural log. So the top will be the natural log. The bottom will be the natural log. On the bottom, we'll have the natural log of the base. And on the top, we'll have the natural log of the whatever's inside. Whatever's inside is x. And then we're going to do the same thing for this. So we're going to have an ln on top and an ln on the bottom. The ln on top is going to be whatever's in the bracket inside the log, which is the x, and the bottom will be the base. And so it'll look something like this. We'll have u over v because they're going to use the quotient rule. Therefore, the derivative will be u dash v minus u v dash over v dash, v squared, I mean. Now, for this bit up here, we're going to need a bit to solve that. So let's start with u dash, which is the top part. U is equal to ln x multiplied by ln of x over ln of 5. Okay, let's do the derivative. Well, we can first, what we're going to do is we're going to scratch this out and multiply it onto the top. This top half will be a, and this bottom half will be b. All I did there was just got it from being on the outside and multiplied it on top because it's still multiplied. Anyway, so the bottom is b, the top is a. Therefore, the derivative will be 1 over x ln x ln 5 and we're going to multiply that by a dash b minus a b dash over b squared. Okay, so we still have our x ln x over ln of 5 multiplied by, okay, if a is x ln of x, a dash, well, yet again we're going to need another bit of paper, which is going to say a is x ln of x. Therefore a dash is going to be, we're going to call this one c and this one d. It's going to be c dash d plus c d dash. Derivative of c is, if x is c, then it's going to be 1, d is ln of x, plus c, which is x, derivative of d, which is ln of x, will be 1 over x. And therefore a dash will be ln of x plus 1, because x over x is 1. So we've got our a dash, ln of x plus 1, multiplied by b, which is ln of 5. And get rid of this for the meantime. Minus a, which is x ln x, multiplied by b dash. If b is a number, then it'll be multiplied by 0, therefore we cancel out this, because anything multiplied by 0 is obviously 0. Now, that's going to be all over b squared. That's b is ln 5, so that's going to be ln of 5 squared. You can have the squared on the outside, but I like the squared on the inside, it looks a bit neater. Okay, so that's what we've got. Now, we've got to try and find a way of simplifying it down. So, because we have a fraction, and on the bottom we have another fraction, we're going to, we flip it. I'm trying to think of the fancy way. There's a fancy way, well, not a fancy way of saying it, it's just the proper way, but I just forgot. So, but all you essentially do is flip the fraction. So basically, the ln's on the 5, and you just take it right to the top. So you flip it. Okay? And then we're going to multiply that to the ln of x plus 1. And ln of 5, that's going to cancel out. We're going to have that cancel out in the bottom. And that's going to be over ln of 5, because we've only got 1 now on the bottom. That's going to cancel out, that's going to cancel out. And we're going to be left with ln of x plus 1 over x ln of x. And that is our u dash. Okay, now we have our u dash, which is ln of x plus 1 over x ln of x multiplied by v, which is just ln of 2 minus u, which is, well, the whole bit at the top, ln of x ln of x over ln of 5 multiplied by v dash, which will be 0. Therefore this whole bit cancels out. And the bottom is v squared, which will be ln of 2 squared. Okay, so what we're going to do here, okay, so we are going to cancel out one of these, cancel out that on the top. Now we're going to have a fraction above another fraction. That means we drop the bottom layer of this fraction, and I'll show you what that means. ln of x plus 1 over x ln of x ln of 2. And that is your answer. All we did here, we just brought this up to a negative power and then brought it down. And that is your derivative. Now, I'll get on to my third example. My camera's about to die, so I might have to rush this little. We have x to the power of x. Okay, how do we solve this? Well, you may not know this, but this is the same as e to the power of ln of x multiplied by x. Why would you say that? Well, there's a rule that says e to the power of ln of x equals x. So what we've done is just sub that for that. See how we did that? And we don't have the x to the power because, well, that becomes that, and the power just multiplies onto this. I'm not going to try and overcomplicate it. This is that, and the x is still the power, but we've now made the x up here as well. Anyway, that's a rule. Deal with it. The derivative. We're going to have to call this bit u and this bit v. This bit stays the exact same, like with every time you derive an e function. It stays the exact same, but then you multiply it by the derivative of whatever's up on the power, which is u dash v plus u v dash e to the ln of x multiplied by x u dash. If u is x ln of x, then the derivative is 1 over x. V is multiplied by x plus u ln of x multiplied by v dash, which should be multiplied by 1. Don't need to worry about it then. This, I'm going to convert this back to x to the power of x, because this is the exact same as x. We agreed that at the very beginning. And it's going to be multiplied to 1, because x over x is 1, plus ln of x. Now you can rearrange that, so you have x to the power of x, ln of x plus 1. But that is the derivative of x to the power of x. I hope you learnt something. Thanks for watching. Have a good day.